In geometry, we talked a lot about circles and some particular information about circles. However, in this class, we're going to focus more on circles plotted on a rectangular coordinate plane. So from geometry, we all know the shape of a circle. We know that the length from the center of the circle to the outside of the circle is called the radius. We know all radii of a circle are congruent. That was one of our postulates. We know that if we put another radius to the other side of the circle, 2r is equal to the diameter. We know the circumference of a circle is pi times diameter. We know that the area of a circle is pi times radius squared. We talked about sectors of circles. We talked about areas of those sectors, circumference of just a part of a circle. A lot of those things will get touched upon again in trigonometry. So let's talk about circles graphed on the coordinate plane. So the standard equation of a circle is x squared plus y squared equals r squared. And that's the circle that's centered at the origin. So if I go back over here and I draw a coordinate plane, oops, that's not a good line. If I draw a coordinate plane here through the center, and I know the length of the radius r, the equation of the circle is going to be x squared plus y squared equals r squared. Not all circles are centered at the origin. So we're going to call h comma k the center of the circle. Now, h comma k is just an ordered pair like x, y. It's just for the coordinates of the center, we're going to give it different variables. So if you have a circle that's not centered at the origin, we're going to write the equation x minus h squared plus y minus k squared is equal to r squared. If you don't see it, that equation of a circle is really just the distance formula. If you're wondering why is it the distance formula, think back to what the distance formula is. It's the square root of 1x minus another x squared plus 1y minus another y squared. Since this is r squared, if you take the square root of both sides, you get the distance formula. All right, I'm going to get rid of those. Let's look at example 1. Write the standard form of the equation of a circle that has a center at -1, -3, and whose radius is the square root of 2 over 2. We're going to call the center h comma k. So when we plug into the circle formula, it's going to be x minus h is -1 plus y minus k is -3 is equal to the radius squared. And then we're going to simplify this. Remember, your double negatives make positives, so this is really x plus 1 squared and y plus 3 squared. And the square root of 2 over 2 squared, if you multiply it by itself, you get the square root of 4 over 4. And the square root of 4 is 2, and 2 over 4 is 1/2. So the equation, x plus 1 squared plus y plus 3 squared is equal to 1/2, is the equation of the circle whose center is at -1, -3, and whose radius is the square root of 2 over 2. Now let's talk about graphing a circle on the rectangular coordinate plane. So if I give you the equation x minus 3 squared plus y plus 4 squared is equal to 16, the center, I'm going to write the general equation underneath of it. H in the center is going to be 3 because 3 is the number in place of h. But I want you to notice that the general equation, k is, it says y minus k, and in the equation it says y plus 4. Well, k is going to be -4. The easiest way to figure out what the center is, set each of those parentheses equal to 0 and solve for x. So if you set x minus 3 equal to 0, you find out that x is 3. That's your x coordinate of the center. And if you set y plus 4 equal to 0 and solve for y, that's your k coordinate, or your y coordinate of the center. So the center is at 3, negative 4, which is right here. The radius is going to be 4, because the radius squared is 16, so the radius is 4. You don't have to make it plus or minus because you can't have negative radius. So the best way to graph the circle, since all radii of a circle are congruent, I would start by putting a point 4 units to the right of center, and then I would put one 4 units to the left of center. I would put one 4 units above the center, and I'd put a point 4 units below the center. And then you'll be able to draw your circle, and it's fairly accurate. Now let's do something a little more difficult. Write the standard form of the equation of a circle that is tangent to the x-axis and has its center at negative 5, 4, and then graph it. We're actually going to graph it first and then go backwards and find the equation. In geometry, tangent lines on circles were lines that hit one point on the outside of the circle, and it was perpendicular to the radius. A tangent line was a line that touched one point on the outside of a circle, and it was perpendicular to the radius. The reason that's important is because once I graph the center at negative 5, 4, so 1, 2, 3, 4, negative 5, 1, 2, 3, 4, here's negative 5, 4. I know that the x-axis is going to be perpendicular to the radius. Well, that must mean the radius is 4 because the center is 4 units away from the tangent line. So I know the radius is 4. I know the center is at negative 5, 4. Well, that's all you need to know to write the equation of the circle. Well, now that I know the radius is 4, I'm going to also put a point 4 units to the right, 4 units above, and 4 units to the left. Not a very good circle, so I'll try again. And there's my circle. And notice the x-axis is a tangent line to that circle. Now we can write the equation. So I'm going to write the general form again. I like to write this every time. It helps me fill out the equation. So h is negative 5. K is 4. And the radius is 4. So the equation of the circle must be x plus 5 squared plus y minus 4 squared is equal to 16. If you were to multiply out the x, if you were to multiply out x minus h squared plus y minus k squared equals r squared, you would get this equation, the general equation of a circle. The general equation of a circle is the equation that is not written in factored form. The problem with that is, when it's not written in the factored form, I don't know where the center is, and I don't know what the radius is. So we're going to have to do algebra to determine what it is. This is how the algebra works. Let's look at example 3. The equation of a circle is 6x squared minus 12x plus 6y squared plus 36y equals 36. Write the standard equation of the circle. Because this is a factored form, we're going to have to rewrite this equation so that we can factor it. So first you're going to start with the x's. And you're going to write 6x squared minus 12x, and then you're going to put a blank. Because we're going to add a new number to this equation in a minute. You're going to do the same thing with the y's. 6y squared plus 36y plus blank. There's a rule about equations. Since I'm going to add 2 new numbers to the left, I'm going to add 2 new numbers to the right. Actually, I should go backwards here. There's a nicer way of dealing with this problem. I want you to know that everything in this equation is divisible by 6. So I'm going to divide everything by 6 first. It's going to make it look a little bit nicer. So it's x squared minus 2x plus y squared plus 6y equals 6. Now I'm going to go back and I'm going to do what I just did a minute ago. X squared minus 2x plus blank. Y squared plus 6y plus blank is equal to 6 plus blank plus blank. When we fill out the blank, we're going to do something called completing the square. Back in Algebra 1 and Algebra 2, we had something called a perfect square trinomial. Perfect square trinomials were really nice because they had a very nice factored form. Some examples of perfect square trinomials are x squared minus 10x plus 25. It's a perfect square trinomial because the last term is a perfect square. It's a number times itself. But the middle term is that same number plus itself. In factored form, this is x minus 5 squared. X squared plus 6x plus 9 is also a perfect square trinomial because this is 3 times 3 and this is 3 plus 3. It factors into x plus 3 squared. Remember, you find the factors by determining the two numbers that multiply to give you the last term but add to give you the middle term. And since in the first case both those numbers are negative 5, when you write x minus 5, that's the same as x minus 5 squared. In the second one, the two numbers that multiply to give you 9 add to give you 6 are 3 and 3. So you write x plus 3, but that's the same as x plus 3 squared. So if I go back here, to find the number that completes the square, you have to ask yourself, what number plus itself is the middle term? Well, the only number plus itself that gives you 2 is 1. So 1 and 1 is 2. 1 times 1 is 1. In factored form, this will be x minus 1 squared. Because I added a 1 to the left, I'm going to add a 1 to the right. All right, now in the second parentheses, since the middle term is 3 plus 3, the last term must be 3 times 3, or 9. So the second factored form is going to be y plus 3 squared. And then the right-hand side, which is going to be my radius squared, 6 plus 1 plus 9 is 16. Once it's in factored form, it's really easy to determine the center and the radius. H is 1, k is negative 3, and that's your center. And the radius is the square root of 16, which is 4. Again, what you can do, if you're looking at this going, I don't know how you knew that was the center, set the parentheses equal to 0, solve. The first coordinate is 1, and the second coordinate is negative 3. And then r squared equals 16, so you just square root. In order to practice something that we did earlier in this semester that will be on your final exam, we're going to talk about writing an equation of a circle if I give you 3 points on the outside of a circle. Write the standard equation of a circle that passes through the points 7, negative 1, 11, negative 5, and 3, negative 5. So the standard equation was x squared plus y squared plus dx plus ey plus f equals 0. What we're going to do is we're going to create 3 equations with 3 unknowns. The first equation I'm going to write, I'm going to plug in 7 for x and negative 1 for y. So I'm going to get 7 squared plus negative 1 squared plus d times 7 plus e times negative 1 plus f equals 0. The second equation, I'm going to plug in 11 for x and negative 5 for y. So it's going to be 11 squared plus negative 5 squared plus d times 11 plus e times negative 5 plus f equals 0. My third equation, I'm going to plug in 3 for x and negative 5 for y. 3 squared plus negative 5 squared plus d times 3 plus e times negative 5 plus f equals 0. And now I'm going to simplify this by multiplying all this stuff out, and I'm going to move it over to the right-hand side of the equation. So equation 1 is going to be 7d minus 1e plus f equals 49 plus 1 is 50. When I move it to the other side, it becomes negative 50. The second equation is going to be 11d minus 5e plus f equals 121 plus 25 is 146. When I move it to the other side, it becomes negative 146. The third equation is going to be 3d minus 5e plus f is equal to 9 plus 25. It's 34, but when I move it to the other side, it becomes negative 34. This is going to give me a matrix. And I'm going to solve that matrix using the graphing calculator to figure out what D, E, and F are. Once I know what D, E, and F are, then I can go find the standard equation of the circle. This is a 3x4 matrix. It has 3 rows and 4 columns. To plug this in the calculator, you're going to go to second x to the negative first. That's the matrix function. And then you're going to scroll 2 to the right to edit, and then hit enter. If it does not say 3x4 at the top, you're going to change it by hitting 3 enter, 4 enter, and then you're going to enter each of these numbers into the matrix. Remember to hit enter after each entry. Also remember to go back and double check that you plugged in the right numbers, because if you accidentally make something positive that should be negative or vice versa, it'll throw off the whole problem. Once all your numbers are plugged in, you then quit, which is second mode. And then you go back into matrix a second time. But this time you only arrow 1 to the right to calc, and you look for option B, I think it is. That sounds right. It doesn't say number B. It just says B colon RREF, and then you hit enter. Then RREF with an open parentheses comes on the home screen of your calculator. Then you go back into matrix a third time. But this time you just stay on names, and I always put my matrices in matrix A, so it doesn't matter if there's anything else in there. So just hit enter twice. And the solution is the last column. The last column should be negative 14, 10, 58. This is D, this is E, this is F. So now I know that the general equation of my circle is x squared plus y squared minus 14x plus 10y plus 58 equals 0. Except this doesn't tell me what the center and the radius are. So now I have to go back and do what we did in the last problem. We're going to do this thing called completing the square. You start by putting the terms with the x's together and a blank, plus the y's get their own parentheses with a blank, equals, I'm going to move negative 58 over to the other side, and since I'm adding 2 new numbers to the left, I'm going to add 2 new numbers to the right. All right, in order to figure out real quickly what number goes in the blank, another way of looking at this is to divide the middle term by 2. Because 7 plus 7 is 14, so you want the blank to be 7 times 7, which is 49. In order to figure out what goes in the blank, you can take the middle term and divide it by 2, and then square it. And that'll tell you what goes in the blank. The reason we do completing the square is because it's easy to factor. The first one is, this is 7 times 7, 7 plus 7, so it's x minus 7, which is x minus 7 squared. Because this is 5 times 5, and this is 5 plus 5, it factors into x plus, or y plus 5, which is y plus 5 squared. And then negative 58 plus 49 plus 25 is 16. I don't know why every single problem we've done has had a radius of 4, but that seems to be what's happening. So now I know the center of this circle is at 7, negative 5, and the radius is 4 because it's the square root of this. In problem 5, write the equation of a circle that passes through the point 1, 5 and has its center at negative 2, 1. All right, well, at least I know h and k. What I don't know is the radius. But I do know that the line that goes from the center of the circle to some point on the outside of the circle is going to be the radius. If only I knew the length from the center to the outside of the circle. Distance formula. Ah, the distance formula. Subtract the x's and square them. Subtract the y's and square them. So I'm going to get negative 3 squared plus negative 4 squared. 9 plus 16 is 25. So the distance is 5, and that's my radius. So the equation of the circle must be x minus negative 2 squared plus y minus 1 squared is equal to 5 squared, or x plus 2 squared plus y minus 1 squared is equal to 25. What if I want to write the equation of a circle that has endpoints of a diameter at 2, 3, and negative 6, negative 5? Well, if I know the endpoints of the diameter, there are a couple ways of figuring out the radius of the circle. The radius of the circle is half the diameter. So if I find the length of the diameter and divide it by 2, I'll know the radius. But another way of doing this problem is to first find out where the center of the circle is. The center has to be the midpoint of those two endpoints of the diameter. So if I use the midpoint formula, I'm going to find h and k. The midpoint formula, add the x's, divide by 2, add the y's, divide by 2. So negative 4 over 2 and negative 2 over 2 reduces to negative 2, negative 1. So I know h and k. Now I need to find the radius. It's probably easier now to find the radius by finding the distance from the center to either endpoint. I'll just pick the first one. So the radius is going to be the square root of, add the x's, square them, add the y's, square them. Not add them, subtract them. Try that again. Negative 2 minus 2 squared plus negative 1 minus 3 squared. So I get the square root of negative 4 squared plus negative 4 squared, which is the square root of 16 plus 16, which is the square root of 32. And it doesn't even matter what the square root of 32 is, because now when I go plug this into the equation of the circle, where the center is at negative 2, negative 1, the circle is x minus h squared plus y minus k squared is equal to the radius squared. The square and the square root end up canceling each other. X plus 2 squared plus y plus 1 squared is equal to 32. And that is the equation of the circle whose endpoints were at, where were they at? 2, 3, and negative 6, negative 5. And that is section 10.2 on circles.